Okay, lesson 5 of rational numbers, powers, and polynomials is getting into what the definition of a rational number is and how we're going to work with rational numbers. Now, here's a big secret, is you've secretly been working with rational numbers a lot already in this unit. Because what a rational number is basically a fraction. So a rational number is a ratio of two whole numbers, okay, like A over B, where A and B are whole numbers, so no decimals, nothing, where B does not equal 0, okay, and that rational number, when it's worked out, because that fraction line actually indicates division. Remember, we talked about that in the very first unit, or the very first lesson. Okay, so when you actually do divide A by B, you either get a terminating decimal or a repeating decimal. The types of numbers that do not either terminate or repeat are called irrational numbers. And probably the most famous irrational number we use is pi. Pi never ends and it never repeats. Okay, so the numbers we're going to deal with, the ones that are rational, are terminating or repeating. So terminating is something like 1.25. It ends. Just no numbers after the 5. There's zeros. You could add zeros. We could secretly add lots of zeros. But there's no more of that number after the 5. Okay? A repeating is something like 0.33333333. We know that's 1 over 3. When you actually divide 1 by 3, you get 0.33333. And on into infinity. We have a special way of indicating that something repeats. In mathematics, we write that like this, 1.3 with a bar over the top. That bar over the top indicates that 3 repeats. Okay, so for example, if we have something like 0.1272727 repeating, we would write that 0.127, and the bar would go across the 2 and the 7. The bar at the top only goes on the numbers that are actually repeating. Okay, so they are an indication of that which is repeating. And it's not an accurate thing to do to plug into your computer 0.3 when it's 0.333 repeating. You'd be much better off putting in your calculator 1 over 3. And if you have any questions about how to use fractions on your calculator, you can come see me in class. I'm pretty good at dealing with all the different models of calculator and helping you figure out what the buttons that will help you the most are. So let's take a look, continuing on, at comparing rational numbers. How do I know which one is the largest or the smallest, depending on what you've been asked? Well, look at the first one, 4 over 7 and 2 over 3. Which one do you think is the largest? There's a couple different ways that you can approach this. We can use equivalent fractions. We could put them both over, I think the lowest common multiple here is 21. So we could put them both over 21 and say you get 14 over 21 for 2 over 3 and 12 over 21 for 4 over 7. So 2 over 3 would be larger. There's an easy way, considering that we all have calculators and we're all going to use them. What we're going to do is we're just going to actually do the division and make them into decimals, okay? So 4 over 7 as a decimal is 0.571428, all repeating. Okay, when you put that into your calculator, hold my calculator up, you'll see that it starts to repeat after the 8. Okay, now let's try 2 over 3. 2 over 3, I know because I use this conversion a lot, and you will be familiar with this after a while too, is going to be 0.6 repeating. All right, remember 1 over 3 is 0.3 repeating, so it makes sense that 2 of those is 0.6 repeating. So we got 0.6 repeating. So which one's larger? The 0.6 repeating is larger. So you're going to have 2 over 3 is larger than 4 over 7. Okay, or conversely, you will write 4 over 7 is smaller than 2 over 3. Okay, so let's look at another example when we're comparing them. 17 over 20 and 0.6 repeating. So I've already got one of them in decimal form. Great, that makes my life so much easier. 17 over 20, if I multiply 20 by 5, I'll get 100. So if I multiply 17 by 5, I'll get 85. So 17 over 20 is 0.85. I just converted that into a fraction over 100, which is the same as having a decimal to the hundredths position. Okay. So remember that this is 0.0666 to infinity. And that leaves it pretty clear that 17 over 20 is larger than 0.6 repeating. Okay, so when we're converting, we have to make them the same thing. We're either going to make them decimals, which is base 100, base 10, base 1000, depending on how many digits you have, or you can convert them to fractions with the same denominator, which sometimes can take longer unless they're fractions that you're really comfortable working with. Okay, so the last little section that we're going to do with this beginning idea of rational numbers and comparing them and ordering them and getting an idea of their relative sizes to each other is we're going to, instead of just comparing 2 of them, we're going to order them, which means we're going to compare each to each to each and put them in order. And in this case, note the question says from least to greatest. Okay, so sometimes it'll say from greatest to least. You got to watch out for that because that's an easy way to lose some marks on a question. You have to keep your eyes peeled for what the question's actually asking you to do. So let's look at that first one. We've got 0.4, it's negative, negative 3 over 5, and negative 1 over 6. So let's start with all of our conversions. So this is, oops, that's not what I wanted to do. Let's go back to blue. This is actually negative 0.6. And this one is negative 0.16 repeating. Okay, so there we go. I've got negative 0.6 and negative 0.16 repeating. So which one's the smallest? Now, these are negative numbers, so this is something you have to really pay attention to. When you think about your number line, got 0 in the middle, 1, 2, 3, negative 1, negative 2, negative 3. Okay, as you go this way, it becomes greater. So what you really want to ask yourself is, which numbers of these negative numbers are the closest to 0? Let's put the negative numbers on here. Okay, so we've got negative 0.6, negative 0.4, and negative 0.16. Huh. So what's actually the largest number? The largest number is the negative 0.16 repeating. That's our largest number. Okay? Negatives work exactly the opposite of what you'd be expecting when you're ordering. So in this case, the answer is going to be, okay, negative 3 over 5, negative 0.4, and negative 1 over 6. Do you notice how I wrote those in the same format they were given in the question, not in their decimal equivalents if they're not already decimals? That's a proper format for writing an answer, and I'll be looking for that on assessments. Got one more here. Again, all negative numbers. It's something really important to practice, and it's something a lot of students struggle with, is this idea that a small negative number is larger than a big negative number. Because when it's more negative, it's actually becoming smaller. So it's a bit of a difficult concept, so I put 2 negative examples on here just to practice. So let's look at the negative 2.8. Okay, negative 2.8, we don't have to worry about. Negative 2 3/4, negative 2.75, okay, negative 2.75, and 3 over 5, we already know is negative 0.6, or sorry, is 0.6, so that's going to be negative 2.6 like that. So negative 2.8, negative 2.75, and negative 2.6. So we know that the larger it is, if it's negative, the smaller that absolute value. So in this case, the answer is negative 2.8 is the smallest. Negative 2 3/4 is the second smallest. Negative 2 3/5 is the largest. Okay, we're going to practice this in class, and you have to pay very close attention to your negatives and positives because they make a really big difference.